Hello everyone, my name is Jane Frances Salazar, and these are my group mates, Kat Palos Palos, Renz Carlo Manuzon, Adriel San Pedro, and Jinwell Barnagea. And we are going to discuss the renewable energy. And first, we are going to discuss the wind turbine. Wind turbine is a type of renewable energy that harnesses the power of the wind to produce electricity. And wind turbine uses rotor with attached blades to collect wind's potential and kinetic energy. Yung wind na yon turns the blade which spins a shaft that is connected to the generator. And nagre-result ito ng generation of electricity. And wind farm ang tawag sa large number of wind turbine. Next, we are going to discuss the parts and operating principle of the wind turbine. Ito ang mga parts ng wind turbine. Ito yung blade, the rotor, and sa wind direction na ito is patulak dun sa blade. And ito yung nagkakos ng pag-spin ng blade. And dito sa nozzle na ito, itong sa loob ng nozzle, and makikita natin ang low speed shaft, the brake, the gearbox, the generator, the collector, the anemometer, the brake, the yaw drive, yaw motor, and the blades. Ay, dito sa nozzle na ito. And sa labas naman is makikita natin ang hub na yung nagko-connect sa blade and ayun, the blades tower. And ito yung dito sa babang bahagi na ay itong baba na ito is makikita natin yung transformer. And next, ganito ang itsura ng isang wind turbine. Tinutulak ng wind ang isang blade at pag ito umiikot, nagpuproduce ito ng pag-ikot ng mga controller ay yung parts ng nozzle, sa loob ng nozzle. And first, we are going to discuss the blade. The blade is the part that rotates due to the force it catches from the wind. It is connected to the low-speed shaft by a hub. And yung low-speed shaft na yun is connected to the gearbox. And yung gearbox is connected siya sa generator. The wind turbine consists of 3 blades for maximum efficiency. Yung maximum efficiency lang ng isang wind blades is 3 lang. Kasi kapag naging 4 yon or 5 is pabagal na yung pag-ikot niya. And once the blade rotates, it causes the rotation of the generator and nagpo-produce ito or nagge-generate ito ng electricity. The blades are interconnected with the inner or vital parts ng nozzle. Ang nozzle is yung outside part or sa likod ng hub na ito. And the blades are connected with the hub. Kapag umikot na ang blade, the inner part ng nozzle will cause ng rotation. Next, we're going to blade design. Wind turbine blades need to be large and tall to produce the amount of power. Kailangan yung isang blade or isang wind turbine is matangkad siya. Tulad ng ito, kapag mas mataas ang tower is mas malakas yung wind na magtutulak sa blade. Next naman is it is shaped to generate the maximum power from the wind, the maximum cost. And the shape of to generate the maximum power, yun nga, the designer must consider the cost of materials. The one that should consider is yung blade designing then. And dito din sa large and wind turbine blades need to be large and tall to produce the amount of power. The longer the blades, the better because it better capturing ng kinetic energy coming from the wind. Next naman is yung the length vary around 50 meter with 107 meter. Currently, the largest from Siemens Gamesa. Yung blade design naman, improvements in the design has produced new wind turbine which are more compact and quieter and generates more power from less wind. Dito rin sa length vary from around, yung makikita sa largest from Siemens Gamesa is ganito yung itsura niya. Ganyan kalaki ang isang blade pa lang yan. And kung hindi natin ma-imagine kung gaano kalaki, tignan na lang natin yung mga tao dito sa baba. Ganyan kalaki ang isang blade. Next naman yung ito, ganito kalaki din yung isang hub ng isang wind turbine. Next naman, sa blade design, yung airfoils. Airfoils is cross-sectional shape of the blades that determines its aerodynamics. And they are key blade design, and this airfoil design allows the blade tips from the wind turbine to move faster than the wind is moving. And also, to generate more power and higher efficiency. Yung cross-sectional ito is ito yung sa kapag itong itsura na ito yung cross-sectional, and yung cross-sectional na ito is may vital part role sa aerodynamics. The cross-sectional makes the blades move faster than the wind velocity, and this shape of cross-sectional of the blade causes the blade to rotate faster than the wind. Than the wind velocity. And also, mayroon ding iba't ibang design ng blades depends sa requirement ng isang power plant. May iba't ibang shape ng mga ganito ng isang blade. And next, wind turbine blades work by generating two aerodynamic forces. Ito yung mga lift force and drag force. This is due to the wind and their airfoils. Yung lift force is the perpendicular to the airflow and it is in line with blade rotation. Ang lift force lang is ito yung force na it makes the blade rotate. Ito yung force na pinaparotate nyo yung blade. And drag force naman is in line with apparent wind direction, which is in opposition of the wind motion. Yung drag force increases in the proportional to the frontal area of the object facing the wind. And yung drag force na ito is a type of force siya na in opposition sa blade motion. Ito yung kumukontra sa pag-ikot ng blade.
Let's talk about the lift and drag formula. These formulas are applicable to the blades of the wind turbine. Like, who would think, di ba, na yung blades pa lang mga nakikita natin na umiikot sa wind turbine, may nakapaloob pala doon ng mga mathematical formulas. At ito nga yun. The first one is the lifting force. The lifting force acting on a body in a fluid can be calculated as F sub L equals C sub L times P times V squared times A all over 2. Where F sub L is the lifting force, C sub L is the lifting coefficient, P is the density of the fluid or yung air, syempre yun yung dumadaloy sa mga blades natin. V is the flow velocity and A is the body area. Actually, the drag force is kaparehas lang nito, nagkaiba lang sa mga coefficients natin. Ayan. The drag force acting on a body in fluid flow can be calculated as F sub D, that is the drag force, equals C sub D, that is the drag coefficient, times P times V squared times A all over 2. Now, mag-proceed naman tayo sa the rule of thumb. The first one, the fewer the blades, the better. Number 2 talks about the number of blades. At yung number 3 naman is the fewer blades reduces the drag. Actually, itong tatlo na to ay magkaka-connect lang. Sabi dito sa number 1, there will be less drag and an increase in efficiency. Mas oonti daw ang blades, mas less ang drag. Less drag means more acceleration. Kapag dumami na yung blades sa wind turbine, mas mag-i-increase yung drag, mas marireduce naman yung acceleration. What do you mean by that? More acceleration, mas mabilis yung magiging ikot ng wind turbine natin. Thus, mas makakapag-produce or mas mabilis makakapag-produce ng energy ng kuryente. Now, the number of blades increases the torque and reduces the optimum rotation speed. It's actually all mentioned in the number 1. Now, let's proceed naman sa mga parts and design ng ating wind turbine. Actually, maraming design yung mga blades ng wind turbine natin, but I only mentioned 2. The first one is the flat blades. Flat blades are the oldest blade design and have been used for thousands of years on windmills. But this flat broad shape is becoming less common than other types of blade design. The flat blades push against the wind and the wind pushes against the blade. The resulting rotation is very slow because the blades that are rotating back on up stroke after generating power are in opposition to the power output. This is because the blades are acting like huge paddles, moving in the wrong direction, pushing against the wind, giving them the name of drag-based rotor blades. That is the flat blade design. The second one is the curved blades. Curved blades are very similar to a long airplane wing. It is also known as an aerofoil or the which has a curved surface on top. The curved blade has air flowing around it with the air moving under the curved top the blade faster than it does under the flat side of the blade, which makes a lower pressure area on top and therefore as a result is subjected to aerodynamics lifting forces which create movement. These lifting forces are always perpendicular to the blades or the curved blade's upper surface, which causes the blade to move rotating around the central hub. The faster the wind blows, the more lift that is produced on the blade, hence faster the rotation. Compare sa dalawa, yung flat blade, yung curved blades, mas nakakapag-blow yung wind sa curved blade. Thus, mas mabilis yung ikot ng ating curved blade design. Let's proceed naman sa blade aerodynamics. Meron tayo ditong, what do you call this? This is a diagram of a blade aerodynamics. Just like an airplane wing, wind turbine blades work by generating lift due to their shape. The more curved side generates low air pressure while high pressure air pushes on the other side of the aerofoil. The net result is a lift force perpendicular to the direction of the flow of the air. So, ito yung diagram natin. Now, you may ask, paano nalalaman yung direction ng wind na direction of the wind na pumapalo dun sa blade natin? Ito yon. The wind turbine is automatically oriented to the maximum advantage of the kinetic energy of the wind from the data registered by the wind vane, this is wind vane and anemometer that are installed at the top. So, yun mismo yung nagde-determine ng wind direction, yung wind vane. Wind vane is where the wind direction, while yung anemometer naman is the speed of the wind. Yun yung nagme-measure ng speed of the wind. The nacelle turns around a crown located at the end of the tower. So that includes my report.
Wind turbine, number of blades. Here is now the question. Based on the previous slides, what number of blades is the best design in consideration of all the factors in construction and operation of wind turbine? Wind turbine number of blades. We already know that the rear of the blade is curved more than the front. This varied shape causes a pressure differential when the air moves across the blade, which is what causes the blades to move. Because of the obstruction of the blade, air moves at a faster velocity behind the blade than in front of it. This is what set the rotation of the blades in motion. Engineers most consider speed and drag in designing the blades to ensure the highest level of efficiency. For example, if too much drag is created by the obstruction of the blades, the power yield will be a lot lower. If not enough drag is created, the blades could move too quickly, causing them to break the sound barrier. The rule of thumb are, the fewer blades, the better, since there will be less drag and an increase in efficiency. The number of the blades increases the torque and reduce the optimum rotation speed. Having a fewer blades reduce drag. Ang one blade, ang sinasabi dito ay ang isang blade ay maaaring maging sanhi ng hindi pagiging magandang balanse. And sa two blade naman ay ang isa sa pinakamainam na configuration para sa isang wind turbine para sa isang perfectong balanse. And more than 3 blade, any number of blades greater than 3 would create greater wind resistance, slowing the generation of electricity and thus becoming less efficient than a 3-blade turbine. The blade tilting mechanism. Ang sinasabi naman dito ay ang blade tilting mechanism ay isang sensor na bibigay bahagi ng wind turbine na kung saan ang blades ay guarantees isang tamang pagkakahanay ng blades sa relatibong bilis. And this 3-blade naman ay isang dinsenyo na may 3 blades ay ang ideal na kompromismo sa pagitan ng mataas na ani ng enerhiya. And then nozzle, the housing at the back of the blade which contain the slow speed shaft, gearbox, generator, and other small parts inside it.
I'm the next reporter po, Jimel Barnachea. Gearbox. So, ang function po nito is kahit mabagal ang ikot ng blade, kaya itong pabilisin ng gearbox. So, papasok ngayon ang gearbox para pabilisin ang ikot papuntang generator. And dahil sa generator, nakakapag-produce siya ng dahil sa gearbox, makapag-produce siya ng mas malaking voltage. So, ang ikot nito is 90:1. So, ano nga bang ibig sabihin ng 90:1? Ang ibig sabihin nun, kapag umikot ang blade ng isang beses, so ang gearbox naman is nakaikot na ng 90 times. Already na yon. So, mostly need ng generator is 1,800 RPM. Pero ngayon, kahit sino di kayang abutin ang ganyang RPM, kaya need si gearbox. Next natin is yung direct drive. Sa direct drive naman is gearless na, at dahil gearless na siya, kung anong ikot ng blade, yun na rin ang ikot ng generator. So para makapag-produce pa rin ng good and high voltage, kailangan dagdagan ang set ng magnet. Unari nga yung 12 set na siya paikot, then kailangan pa nilang dagdagan ng mas marami. Kaya naisip na tanggalin ang gearbox ay dahil isa ito sa mabigat na part sa wind turbine. Kaso nga lang, ang gagamitin na magnet is permanent magnet, hindi siya electromagnet. At ang nagsusupply lang ng klase ng magnet is sa China, and iisa lang ang supplier, kaya napakamahal. And mas malaki ang generator ng gearless kaysa sa gear type. Ganyan kalaki ang kailangan sa gearless. Then ang disadvantage nga nito is slow rotation, more magnet, increases diameter, and larger generator. So mostly lang po ginagamit ay dahil expensive, at ang ginagamit na magnet dito ay ang neodymium. Dito sabi ko nga sa previous slide, ito yung cost. Ito yung cost kasi nga dahil sa neodymium, pero sabi ng mga expert is yung gear type is nasa maximum na yung kanyang development, and yung gearless naman ay mas marami pang improvement na pwede pang ma-discover regarding sa design. Kaya kapag nangyari ito, mas maangat na siya sa gear type. Then ang advantage ng gearless is less vibration kumpara sa gear type. Ang tahimik and tahimik siya during operation. So next, brake. Ang function naman ng brake is kapag na-detect niya na mabilis ang ikot ng turbine is automatically it will shut down the unit. And syempre, di lang yun ang reason kapag naman merong vital parts not work properly, it's automatically shut down the system. Pero mas may high mas high detector pa na kapag may na-detect na maintenance, automatically pinapahinto niya rin yung system. And next, so sa yaw system. Ang yaw system meron ditong yaw drive and yaw motor. Ano nga ba ang function nito? Ano nga ba ang function ng yaw system? Ang wind turbine kasi is hindi naka-fix, kaya may yaw system. Yung yaw system kasi sinusundan niya yung wind direction. So dapat laging nakaharap yung turbine sa wind direction. Ngayon ang hangin kasi is pabago-bago ng direction. Kaya iniikot ng yaw motor ang turbine para sundan ang wind direction. Dapat nakaharap lagi yung blade sa wind. So ang nagbibigay ng information sa yaw motor para humarap sa wind is ang wind vane na located sa dulo ng nasa nozzle. So next naman tayo is sa tower. Ang tower ay cone design, meaning lang nun is mas mababa ay mas mataba sa baba, and sa taas ay mapayat para ma-minimize the cost of the tower. And ang average height is 75 to 100 meter or 250 to 370 feet. And ang pinakamahabang tower or pinakamataas ay 280 meter noong 2022 pinatayo, located in Western Jutland sa Denmark. Next, sa ano naman tayo, wind turbine tower and blade diameter ratio. So makikita dito is yung bawat year niya. So saan natin sa 2000. So year 2000, average hub in height is 58 and diameter niya is 48. So nung 2005 naman, height niya is 75 and diameter niya is 65 meter. Sa noong 2010 naman is ang height is 80 meter, diameter is 84. So noong 2015, height niya is 82 meter, diameter niya is 102 meter. So 2018, ang height niya is 80 and ang diameter niya is 116.
Wind turbine ideal location. The best place for wind farm are in coastal areas, at the tops of the rounded hills, open plains, and gaps in the mountains. Place where the wind strong and reliable, some are offshore. To be worthwhile, there should be an average wind speed of around 25 km. Karamihan daw po ng wind farm ay located sa coastal areas, open plains, and mountain. At para naman po maging sapat ang ihip ng hangin, dapat ay nag-average po ang hangin ng 25 km per hour. Wind turbine parts and functions. Advantage: wind is free, wind farm no need fuel. Walang fuel na ginagamit para mapaikot ang isang generator. Produces no waste greenhouse or gases. Hindi siya nag-i-emit ng carbon dioxide. The land beneath can usually still be used for farming. Pwedeng magtanim or mag-conduct pa ng ibang activity. A good method of supplying energy to remote areas. Dito naman po sa disadvantage, the wind is unpredictable. It changes speed throughout the day and from season to season. Minsan po kasi hindi natin inaakala na merong malakas na hangin pero wala naman pala. Ganon. Suitable areas for wind farms are often near the coastal area where land is expensive. Namimili lang po siya ng location. Can affect television reception on nearby places. Kapag malapit po yung bahay nyo, yung tirahan nyo, magloloko po yung signal o yung TV, signal ng TV nyo. Largest wind farm. Gansu Wind Farm, may capacity po siyang 7,965 at hindi pa raw po ito tapos. Ang plano po nila ay hanggang 20,000 megawatts in China. Alta Wind Energy Center, may capacity po siyang 1,548 megawatts at hindi pa rin po ito tapos. Ang nakaplano po ay 3,000 megawatts in California, USA. Mupandal Wind Farm, may capacity po siyang 1,500 megawatts in India. Hornsea Project 1, may capacity po siyang 1,218 in UK. Mark Bigden Wind Farm, may capacity po siyang 1,120 megawatts. Hindi pa rin po siya tapos at nakaplano po ito ng hanggang 4,000 megawatts in Sweden. Jaisalmer Wind Farm, may capacity po siyang 1,064 in India. Gansu Wind Farm. The Gansu Wind Farm project or Yuan Wind Power based in a group of the large wind farms under construction in western Gansu province in China. In 2008, construction began on a 750 kilovolt or alternative current power line to carry electricity from the wind farm, and construction of the wind farm themselves started in August 2009. In November 2010, officials announced the completion of the project first phase involving the installation of over 3,500 wind turbine with an installed capacity of approximately 5,160 megawatts. It has an estimated cost of 120 billion Chinese yuan of 17.5 billion. The project is being built by more than 20 developers. In 2010 daw po ay 3,500 wind turbines na po ang nagawa. At nag-approximately po ito ng 5,150 megawatts. Burgos Wind Farm. The 150 megawatts Burgos Wind Farm is the largest wind farm project in Southeast Asia located in Burgos, Ilocos Norte, Philippines. The estimated cost for the construction of wind farm was $450 million US, which was completed in 2050, located within a 600 hectare site. The facility consists o 50 wind turbine each with a capacity of 3 megawatts generating electricity to the Luzon grid. Each wind turbine rests on a tubular steel tower, has a 75-meter hub height and a 90-meter rotor diameter. Burgos daw po ay merong 150 megawatts at 50 wind turbine. Compare po doon sa may Gansu wind farm ay napakalaki. 3,500 wind turbine at 5,160 megawatts. Wind turbine grid operation. Dito po is tatamaan po ng wind yung blade and then iikot po ito. Susunod po ay iikot din po yung gearbox. Pati po yung generator and then magge-generate na po siya. Dadaan po sa power cable. Then mapupunta sa transformer. At may susupply na po sa mga consumer, sa mga bahay-bahay.
Next, we are going to discuss the hydrogen power plant. Hydrogen power plant is a concept designed for a new widespread source of electricity. Essentially, it is a facility which uses hydrogen to produce electrical energy. Hydrogen energy involves the use of hydrogen or hydrogen-containing compounds to generate energy to supply all the practical uses needed, which is high energy efficiency, over many environmental and social benefits, as well as economic competitiveness. And the hydrogen energy conversion system are expected to become the choice of the future energy system, and is possible to produce hydrogen from sustainable and renewable sources. It is being proposed that the large facility, not unlike the nuclear power plant in appearance. The cost involved with containing the hydrogen means the overall cost of hydrogen-based electricity will be greater. Next, the working principle of the hydrogen power plant. The large tanks of liquid hydrogen will feed into 1,000 hydrogen fuel cells. And this hydrogen fuel cells is nag-contain siya ng these fuel cells are solid structure containing an electrolyte fluid and two terminals and nagwo-work siya like batteries. And the reactants flow into cells, in this case hydrogen and oxygen. They intermingle with the electrolyte to produce an electrical charge and water as an byproduct. Next, the water flows out another part while the electricity is phoned off the terminals and held in gigantic multi-ton batteries. And the electricity resides in the batteries until it is needed, in which case it is sent out through the local power grid just like any other type of power plant. Next, the battery parts. The electrolyte, the chemical compound that conducts electricity by changing into ions and melted or dissolved into solution. Ang electrolyte ay contain siya ng or gawa siya sa ammonium chloride, zinc chloride, potassium hydroxide, and sulfuric acid. Next, an electrolyte then is it can be a liquid or paste-like substance. Next, the anode. Negative or reducing electrode that releases electrons to the external circuit and iodizes during the electrochemical reaction. And sama ng mga ito is zinc, metallic lithium, and lead. Ang anode naman, ito yung sa negative side ng isang battery. Next naman is the cathode, the positive or oxidizing electrode that acquires electrons from the external circuit and is reduces during the electrochemical reaction. An example naman nito is the manganese dioxide, carbon, lead dioxide, and copper. And ang cathode naman is ito yung positive side ng isang battery.
Since it's already mentioned that the hydrogen fuel cells act like a battery, now let's talk about how a battery is constructed, or ano ba yung mga nasa loob ng isang battery. Parang dito sa picture, yung battery ay parang binuksan para makita natin kung ano ba yung mga nasa loob niyan. Ito siya, siguro ito talaga yung itsura ng isang battery kapag hinati mo sa gitna, di ba? Hindi pa ako nakakita. But first, dito muna tayo sa upper part. This is the metal cap. Itong parang coin na to. Now, what is the metal cap? Metal cap on an electric cell is considered as the positive terminal of the cell, which is defined as the electrode that receives the electrons. It is also called the anode. So, ito pala yung anode part, which is the positive side of a dry cell or yung battery natin. The second one is the carbon rod. Ito siya, yung parang tube-like na nakakonekta hanggang sa baba. Carbon or graphite rod can be used as an electrode in any of a number of electrochemical experiments, such as the electrolysis of water and the construction of an arc light or arc furnace. The zinc case naman, yung zinc chloride cells are usually marketed as heavy-duty batteries, used as a paste primarily composed of zinc chloride, which gives a longer life and steadier voltage output compared with an ammonium chloride electrolyte. Meron din tayo ditong moist paste of ammonium chloride. Itong white part na yan, this is the moist paste of ammonium chloride, which is a strong electrolyte. Ammonium chloride is a strong electrolyte. In a dry cell, the electrolyte ammonium chloride forms ammonium ion and chloride ions. At yung bottom part, this is the metal bottom. Meron tayong metal cap dun sa may taas at meron naman tayo dito metal bottom. Kung nakakita na kayo ng battery, meron dun yung battery, merong wala kasi ang battery. Meron dong parang sa kabilang dulo, flat. Yung isa naman, meron naka-usling onting-onti lang na metal. Yung flat na yon, that is the metal bottom. Those metals help to create a strong and durable framework for the battery. At yung metal bottom din na yon is the cathode or the positive terminal of the battery. Now, you may ask, how does batteries work? So, ayan. Batteries have three parts. Meron tayo sa taas yung cathode, or that is the positive side, the electrode, positive side of the battery. Sa gitna, ito yung electrolyte. Sa baba, meron tayong anode. Now, the cathode and anode is the positive and negative side at either end of a traditional battery. They are hooked up to an electrical circuit. Now, explain muna natin further, di ba ang battery gumagana siya para paganahin yung isang appliances na hindi naman nakakonekta sa isang plug. Halimbawa, yung flashlight. Kung i-imagine natin na yung flashlight ay gagamitin natin habang naka-charge, that is so inconvenient. Kaya kinakailangan natin ng battery para madala natin yung flashlight kung saan-saan. Now, paano bang gumagana nga yung battery para makapag-produce ng electrical energy sa flashlight para gumana? The chemical reactions in a battery causes a build-up of electrons at the anode. So, yung sinasabi dito, merong mga build-up of anodes dito. Now, yung mga anodes na yon, yung mga electrons sa anode, pipilitin nilang makapunta dun sa may positive terminal, which is the cathode. Kaso, pipigilan ng electrolyte na makapunta yung mga electrons dun sa may cathode, kaya magta-travel sila dito. Magta-travel sila sa path na to, na pwede lang sila makapag-travel sa path na yon kung naka-closed yung circuit. Kaya sabi dito, in a battery, the only place to go is the cathode. But, the electrolyte keeps the electrons from going straight from the anode to the cathode. So, yun pala talaga yung pumipigil na makapunta yung electron sa cathode. Now, kapag naisara na yung circuit, halimbawa wala nang path yung circuit, hindi na nakasaksak. A wire connects to the cathode and the anode. Yung sinasabi dito the electrons will be able to get to the cathode. Ngayon, pag isinara natin itong light bulb na ito yung switch, kumbaga, makakapunta na yung mga electrons sa anode, yung mga excess electrons sa anode, makakapunta na dun sa may cathode. At kapag nangyari yon, makakapag-produce na ng electrical energy yung battery. Yun ay makakapagpagana sa isang appliances. That includes my report.
Cell card. Anode is the negative or reducing electrode that release electrons to the external circuit and oxidize during the electrochemical reaction. A membrane only allows the positively charged hydrogen ions to pass. In cathode, the cathode is the positive or oxidizing electrode that acquires electrons from the external circuit and it's reduced during the electrochemical reaction. Electro engine function by plugging into a charge point and taking electricity from the grid. Power electronics. Power electronics convert and distribute electrical power to other vehicle systems such as heating and ventilation, lighting, and infotainment. Batteries provides the sap of electricity needed to put electrical components to work. And last is hydrogen tank. Hydrogen is pumped into the cell through a flow plate. Hydrogen fuel cell working principle. Fuel cells work like batteries, but they do not run down or need recharging. They produce electricity and heat as long as fuel is supplied. A fuel cell consists of two electrodes, a negative electrode or anode, and a positive electrode or cathode, sandwiched around an electrolyte. A fuel such as hydrogen is fed to the anode and air is fed to the cathode. In a hydrogen fuel cell, a catalyst at anode separates hydrogen molecules into protons and electrons, which take different paths to the cathode. The electrons go through an external circuit, creating a flow of electricity. The protons migrate through the electrolyte to the cathode, where they unite with oxygen and the electrons to produce water and heat. The central controller model is one component is designed as the controller and is responsible for managing the execution of other components. The central controller models fall in two classes depending on whether the controller components execute sequentially or in parallel.
And the next reporter, Jumal Banik. Fuel cell hydrogen power plant. Ang tanong po dito is, why store it? Kasi ang hydrogen is a very efficient fuel source and capable of producing more energy per pound of fuel than gasoline. And meron na ring hydrogen car. Ang pinagkaibahan nila ng gasoline car, kapag pinagkumpara natin sila ng gasoline and same volume of hydrogen, mas malayo ang nararating ng hydrogen car. Mas maganda ang hydrogen car. Fuel cells have much lower emission than combustion engines, and fuel cells are quiet during operation. So, tahimik siya. At ang kagandahan din dito ay no carbon dioxide emissions, no air pollutants. Kaya maganda ang hydrogen power plant. Kasi kahit na malapit ito sa tao, hindi sila naapektuhan. So ang susunod na tanong is ang why it has gone mainstream. Una is yung hydrogen production through methane. So dito naman is extract ka ng methane through hydrogen, nagpo-produce ito ng greenhouse gases. Di ba ito ang iniiwasan natin? Tapos mag-produce ka pa ng carbon dioxide, so hindi maganda sa ating environment. Next is yung hydrogen production through water. Ito naman ang paraan para makapag-extract ng hydrogen besides steam reforming. Then the production method is electrolysis, which separates hydrogen from water. Hindi maganda pakinggan, magandang proseso. The downside is that it's expensive. So ang reason kung bakit hindi present, dahil ito ay mahal ang proseso. So next natin is yung cost. The cost of fuel cells can be high given the use of platinum. Ito yung pinakamalaking component material. Alam naman natin lahat na ang platinum is expensive than gold. Pero gumagawa na sila ng paraan para palitan ang platinum at the catalyst hydrogen fuel cell. So next is yung hydrogen storage. So dito walang major manufacturer na willing mass produce of tanks para sa hydrogen. So merong mga company na nagtayo ng hydrogen power plant pero nasa prototype stage pa rin. Kaya yun ang major practical disadvantage. So next natin is yung hydrogen leak. So dito naman, during operation, hydrogen leak is possible. So if nagkaroon ng hydrogen leak, naapektuhan nito ang ozone layer na mas mabilis pa sa CFC. So ano nga bang CFC? Chlorofluorocarbon. It means mas malala pa ang epekto ng hydrogen sa ozone kaysa sa CFCs. Yun lang po. Thank you.
Latest development. Long Range Energy Generation Project. Touted as a first of its kind power plant in the United States. The Long Range Energy Generation Project is a 485 megawatts facility being equipped to run on a mix of natural gas and carbon-free hydrogen. Is nearing completion at the site of a former aluminum smelter on the banks of Ohio River. The facility first will burn a fuel blend that includes 5% hydrogen in a General Electric H-class gas turbine. The plant is intended to transition to 100% green hydrogen over the next decade by relying increasingly on renewable energy to power electrolysis machines that split water into its hydrogen and oxygen elements hearing 2021. Ito daw po ay merong 485 megawatts facility in Ohio at only 5% hydrogen in the contributor factor of 485 megawatts. This project, it comes to using green hydrogen ay nananatili pa rin nasa trial stage. Masasabi natin na itong hydrogen power plant ay still at exploration stage. Latest development. Siemens Energy. Construction begins on world largest green hydrogen power plant, part of unique base load solar project. Siemens Energy will operate the unique 170 million euro facility in a remote part of French Guiana, which will provide 10 megawatts of power during the day and 3 megawatts at night. A unique baseload renewables project that combines the world's largest hydrogen power plant with a 16 megawatts machine for electrolysis of water, a 3 megawatts fuel cells, 55 megawatts of solar panels, and 20 megawatts to 38 megawatts of batteries has begun construction in French Guiana. Collins 2021. This one cost is around 170 million euro and situated into French Guiana. This power plant actually ay offer a little capacity when it comes fuel cells ay meron itong 3 megawatts lamang. Ang majority nito ay ang solar panel, which is 55 megawatts and 20 megawatts to 38 megawatts reserve capacity ng baterya. Yun lang po. Salamat.